Oh, I just copied a hallway in a condo that I live in just absolutely. So anyways, how's it going? Stream, welcome to stream, welcome to this. Trying the Nintendo radio. Alright, so we got Hilbert Curve. What did I do with that Hilbert Curve stuff? Bam 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 bam. This wasn't it. Main Game Jam Space Trader 1. Okay. How far did I get on this? Oh, cool. Okay, that's cool. So we still have that going. That's good. Alright, so, I've been trying to do the Hilbert Curve here with ChatGPT. And is that too loud? Is it particularly the song that's too loud? I'm going to turn that down just a bit. Okay, that looks like it's a little better for folks who might want to actually hear me. Because I've got it turned down quite a bit in my headset, so nice background music though. There we go, that sounds a little better. But no, so I should probably just get going with the Game Jam, what I wanted to do. Hilbert Curve, Game Jam Planets with Voronoi Gems. Okay, so the next thing we want to do, right, okay. Good, good, good. So where is this Game Jam Space Trader? Oh, those are just the, alright, it's been a few days since I programmed. I've been busy getting ready for work. Had a bunch of pre-hire stuff to do to be a security guard at the local casino here. Getting ready for that. Oh, had to watch an hour and a half worth of videos about this and that, which was just, yeah. Excuse me. Actually had to leave the house to go get lunch. Oh, it was awful. Awful. The whole outside world thing happened. Oh. We had beautiful, calm, sunny weather. And then all of a sudden, flash hail. That was nice. Alright, so what are we going to do? Pretty much for this game. What I should probably do, because this is going to be a solar system here. That's the star. And then we'll just draw the planets at random little spots, you know. What we should do is figure this out. We should figure it out. So let's do this. I haven't done this in a long time. We'll create a new class. We're going to call it class. What are we going to call it? Solar system? So far it's the only solar system I've made, I think. So that should work. Let's just open a new file and do this. Boy, I'm actually getting into code here. I thought I would be unable to code. Is this a header file? .h? Yes, it is. Okay. Is this what I call it right here? Okay, now let's take the stuff in here that makes this happen, and then we'll... Okay, we want the class to inherit shader, but this... I think that's how that works, right? How come it's not doing anything? It's all squiggly. Let's open one of the other. Let's go main, space, gems. System space gems class star 1.h. That's a good one. We're just going to copy it over. Okay, so this is going to be a class, solar system, inherit shader. Do I need that in? So then we initialize it, SS. We're going to move that out. Okay, so then we're just going to call it solar system. SS solar system. Want everything to be public, that's fine. We're breaking stuff now. I don't know why that's squiggly. Alright, we'll see if the squigglies disappear. Shader, okay, so I think when we initialize our solar system here, so just like star 1 in the space gems would go like this. Oh, load shaders. Okay, good. So we want to copy this init data, init VA, VBO. Let's just do it exactly. Solar system dot init data. Are we going to call it SS init data? Let's just go like that. Solar system dot SS init VAO VBO. Excuse me. Body's still getting used to the caffeine. Digesting. Okay. I think we just can go like that and go like Uh-oh. That? Okay, good. That'll work. Load shaders goes away, that goes away. Okay. This is your init VABAO. I always say that wrong. So SS init VA. Oops. It's just gonna be void. So there's that. And then right here we go void SS. Alright, the coffee is helping, I suspect. Convert this over. Oh, excuse me. That should work right there. The music is just great, but it's a little bit loud. Turning it down. Okay, so init data we are not doing yet. We need to. Do we have any data to initialize? Solar system dot, let's do that. Solar system dot draw. Solar system. Clear? Okay, that's not a part of the thing, whatever. Delete vertex arrays. Let's put that in the cleanup. Okay, void SS. Clean up. Go back to here. Okay. Main data render, update data cleanup, process input. So far we don't do anything with process input, but we will eventually. Okay, so I may have just broken it and it probably won't work. Yeah. So what's wrong, computer? Tell me your troubles and sorrows. Cannot open include file class underscore solar underscore system 001 dot h. Okay, still got. Excuse me. Sorry, tried to move the microphone out of the way, moved it back just to cough or whatever. Just specifically to give you that extra. Okay, so it's still going squiggly with reading that file. Computer, same thing. So I'm wondering what's going on. Like when I include those kind of files, it's oh, quotes, because it's the directory. All right, I'm with you, Cheech. Hold on. And of course, what are you doing, Visual Studio? Double quotes on both sides. We want 4 quotes. There we go. All right, is it working? Did I break it? Is it restored to its... Oh. This is not... Is this Nintendo? It's the Elder Scrolls on the Nintendo radio. I didn't know that they included that. That's awesome. Makes me kind of miss when I did my... Oh, now it's not even up there. Hold on. Son of a bean dip. Public shader. Oh. Is that the problem? Is it supposed to be a capital S or something? I think I recall. I seem to remember. Is everything fixed? And no. Shader's not a... Okay, so... Alright, hold on. Let's look at class star 1 again. Public shader, so small. Now, are we doing this right? Class that like that. Public shader. Class that like that. Public shader. That looks right. Public star VAO. Now when I included it there, I had this one, shader M2. Am I forgetting my shader stuff here? Now what? That's what I was looking at just before I hit compile computer. It's oh. You're right. There we go. There's no Clash of Code. What's up, sir? Oh, nice, just in time. Okay, so I transferred that over to a class. We got there. There's my star. Do you like my star? It's the star of the show. Okay, let's do a clash. Let's do a clash. I love how the news always shows the most freakiest person, like every single time I tune into the news. Here's a cold-blooded killer. Damn. So how are you, zombie killer whale? How you been? Let's see if we can invite some people. And let's launch. Oh, I start my new job tomorrow. I'm kind of nervous, scared, excited, relieved. Everything all at once. Security guard. I'm good. Hey, live if, whoa. How's it going? I seem to remember talking to you when I was a little bit buzzed. Apologies if I said anything weird on stream. And how you doing? Okay, I gotta stop enjoying the music. It's time to code. Oh wait, is this you? Live if W. E live Iton Walter. Cool. Oh, dude from Brazil. Wow, how's it going? Scary stuff going on there lately. Okay, so what are we doing? Oh, tilapia, 15. Rice, tilapia, 10. Rice, tilapia. Carrots, rice, tilapia. Pizza. Oh. Turkey, 90. 60. Oh. Stuffing, 30 goes to 10. Eggs, salad, steak, fries, cake, gelato. Steak. Oh. Egg. Oh. Fries. Oh. Well, this is distracting right here. For item and input split pass. What does pass do? Rice, 30, tilapia, 40, okay. Now what's this? Sonic Adventure 2. Oh. Nintendo radio's all over the place. I'm liking that. That's a good variety of music. Huh. Oh, I shall have to take a break for some, I know I've only been streaming for like 25 minutes, but I need some juice. Oh, wait a minute. What? Oh. Interesting. Alright, I'm gonna go juice. I'll be right back. You guys, good luck with the clash. Okay, sorry about that. Shoot, had to clean up some garbage, take it out, get the juicer going. Nice. Very nice. Let's do another one. I know, and I'm sitting here drinking cucumber celery juice. If you guys are still with me. Hey, well, thank you. See what we got. Oh wow, parsing an equation. We're getting closer. You got it. Regular expression. I knew it. I was like, this would probably be good for regular expressions, but I don't know anything about it. Which I need to learn. Find all minus question divide d plus. Minus question divide d plus. If E0 dot is digit Q vowels equals vowels. Else Q equals 1. Interesting. I like how I'm actually doing all these. He's like, oh, sure. Believe it or not, this is kickstarting my brain. I don't know if it'll get working yet or not, but By Joe, I may be onto something. Zero, 1, 2, 3. Oh. 0, 1. Yeah, so it's that. Okay. I'm done. I'm gonna get, oh, exactly 50. Okay. Center. Nice. D get I, center. I didn't want to try that. Just happy I got the box. Okay, let's start to work on the solar system here. Okay, so where was that one program that I wanted to use? Is it in here? I didn't list it in there. Game Jam? Did I list it in here? Oh. Planet with Veroni gems. I seem to remember. Stars are a single point. I already got that. Planets are Verona with 1 or 2 color palette drawn at half intensity. Where's that one though? Planets. Oh, nice. Here we go. This. Okay. Cool. Oh, so let's work with that. Boy, that juice is giving me energy. It's better than coffee. System point demo. This looks like init point. Yeah. Okay. Bum, bum, ba, da, da, da. That juice was really good. Number of points 1800. Yeah, that's because it's the little screen. So Voronoi, position color RRT, num points, T points. Oh, I've got the init data right here. Calculate positional point based on I and J. Ti equals that position equals that. Find the nearest Voronoi and set color and RRT based on Voronoi's points setting. Okay. So Ni equals 100 and D equals 100F. CD equals distance between that. Oh, and the Voronoi points, right? Okay. So CD is less than ND. ND equals CD. NI. Okay. Oh, so that's the distance. That's the index, right? Okay, and then the color, right? All right, that's fine. It's been a minute since I've done this. RRT is equal to this up here. Cool, cool. Okay. Very nice. So another thing I wanted to use was the shader. And I can't see a thing. So out, okay, and so there's that. Let's leave that open. This one is just zero, 1, 2, 3. And I messed with all the parameters. It looks like Eclipse, not BSC. Eclipse. Oh, gotta go. Hey, thank you, Zombie Killer Whale. Thanks for the brain kickstart. Always enjoy clashing with you and figuring out I need to know more about everything. It looks like Eclipse. Eclipse is for Java stuff, I believe. Yeah. But no, this is Visual Studio. It is not Visual Studio Code, however. And Skydreamer, hey, welcome to the stream. How you doing? I am trying to make planets right now. Java. Yes, Java. So this is not a very complicated thing. That can fit right in. Not there, this one. Okay, so I think I really got it. Okay, so okay, so when I draw the star, all it is just that position. Okay, so we can so, and then when I draw the I can feel my brain attempting to wake up. How vector 4 color? Cube grid cube color. Okay. Is that C++? It is. And then this part here is the GLSL code. This is the fragment shader. This is the vertex shader, which resembles C++. I believe it does. I'm just so used to it. The juice is attempting to wake me up, and it's really somewhat succeeding. Games use a lot of math. I haven't released a lot of games. In fact, this is my first one. But yeah, graphics coding does use a lot of math. It's crazy. But one thing I like is that a lot of people have done a lot of math already, and you just copy their code. And as long as you understand the underlying principle and you can get it to go input and output and all that, you're probably doing all right. Oh, my brain, I can feel it waking up. This is so bizarre. My brain's just like, are you working on something right now? That's what I get for drinking yesterday a little bit. Whew. All right. Did I have 2 coffees today? I had 2 coffees today too. Wow. Okay. So this out vector 4. Oh right, because this one. Okay, so the other thing it does is platform, uniform, cube, grid, and color. Oh, that will have to change. That's fine though. Because we have a color and then the RT thing. I think with this, because position color RRT. I don't remember what RRT stands for, which is a good lesson to comment your code. But we can use one of those for the grid. That'd be fine. And in fact, it might already be using it here. G equals FRRTG. UV times G. Yep, it is grid. Okay, good. And then float N equals FRRTB. N is, looks like a Y multiplier. And then where's the R? Doesn't look like the, oh wait, R is the type. R is the type. Okay, so type, grid, so N must be scale. Must be the Y scale, excuse me. Or some, yeah, because I don't know, is that a multiplier? It looks like a scale multiplier, okay. So let's go into the let's start from the beginning with this. Where is the solar system class? Okay, now computer. Tell you what I'm gonna do. What we're gonna do. Even the star can be drawn. Oh boy. Okay, so solar system 1. So there's your vertex shader. And that's gonna have to be redone, that's fine. So this is working the way I want it with the thing, but let's go up another version here, just so I have something to fall back on, but I'm not gonna fall back on it, but just in case. Just in case, and we'll switch over to 2 that I can do anything I want. Just like this would go 2. Just like this would go 2. Okay. So then we'll come up here, save that. 2. Save that as 2. What kind of game is it? Yeah, I joined this game jam. Let's see if I've got the stuff here. It is a 2D platformer. First it starts in space. It's a space trader, so you'll start in space, and you just choose a planet, and then you'll beam down to the planet, and then it's going to be like a little platformer. And then the platformer is, haven't quite worked out all the mechanics, but you'll be able to do a little bit of farming, I think, or mining, and get some resources that you'll be able to trade at the station on the planet. And I do have a bunch of mechanics that I thought of, but I'm not sure which ones I'm going to be including. And I had ChatGPT come up with a bunch of names and stuff to help me too. So we'll see what I can include in that. Oh yeah, I was trying to do the Hilbert curve stuff for the background, but I think I could just use the maze stuff, which would be a lot quicker. Because I've already done some maze stuff, which is pretty cool looking. But I would like to add a little bit of variation, not just have a maze background, but have nice little Hilbert curve or other space-filling curve function equation things. But we'll see. I don't know. I have limited time and I start work in the actual world, not of video games, but the world of security guard tomorrow. So it's going to be taking up the majority of my focus and attention, unfortunately. So I may not even get beyond tonight's coding for the for the game jam, which is unfortunate, but that's how it's going to be. Because this game jam isn't going to make me money, but going to work will. So that's the bottom line. That is the bottom of the line. But no matter what, even if I don't finish it within the time frame of the game jam, I'm still going to work on this idea. Even though I previously had another idea that was a space trader, I thought that this was, what do you call it, a dumbed down, easier version to put together. So this one's kind of cool. So I think the first thing I should do is do the data just like the other code and just draw the star the way it is. So I can change this. And this is for the planets, but we can include a different RRT for the star. Okay. I think that'll work. So let's just copy that. So we're not going to need the uniforms anymore. And then this is going to be the fragment shader. However, I'm not going to, because I already have this platform function, we can kind of merge these two, because I don't need to get rid of, okay. And then this should probably be its own function here. If distance GL frag chord, okay, so that's going to be per, what is that? That's the center of the screen. So we need to make that into a function. So the function will take the center. Oh, and it's frag coordinates too. Oh man, I forgot how to do this, but it's going to be window coordinates. So it's not. So each planet that I produce here is going to have a window coordinates center and then a pixel radius. Okay. Alright, I'm with you, Cheech. I'm with you, Cheech. That's going to be different, but that's just because I'm using this GL frag chord to produce the circle for the planet. Okay. Alright. So does it return anything? It's just going to draw, so I don't think, so let's go, let's just call it do planet. And we're going to put it, we're going to send in a float of the, computer, I don't want that. Okay. That was a huge amount of intelligence. So we want, what did I say again? GL frag or window coordinate. Okay, so let's call it win x. Float win y. And then float win radius. Or we could say pixel radius. Alright. And this, you know, I should comment this code so I know. This function uses GL frag board to create the 2D circle. So the parameters are in window coordinates. Excuse me. Pixar is the radius in pixels. Excuse me. Oh, that juice. Digesting. Windex is, excuse me, the window coordinate x. So the parameters window coordinate x. Let's go like this. The window coordinates for the center of the 2D planet. Okay, good. I think that will be enough to describe to future me what we're doing. Okay, and then if distance, all of this, so UV equals that, G equals all this, and that's still going to work. Everything's fine there, good. Okay, else discard. Okay, color, alright. So now we can have that as a function. And so that's FRRTR. There's a joke there. RDRR. Okay. Anyway. Rotation. Okay. What am I doing? Float. Win X, win Y, pix R. Oh right, I didn't even change that yet, so let's do that. So like if I just go here, do planet, and we have the other one that was here before, 960. What was the other one, 480? 580. And then 450. Just as an example, like the previous one, that's not going to work, but that's what we're going to do. That's what we're going to do. Let's copy that, and let's put the parameters in there now. So this is pix R. That's your radius. This is win Y. Okay. And this is win X. Or windex. No. Alright. Color, fragment, color. Okay. Out vector for color. And so we can leave that, that's fine. This is the music, okay. We're grooving. Okay, we're not going to use those uniforms. So we need a way to distinguish between the star that I want to draw and the planets that I want to draw. Okay, right. So we're just going to say this is an example of how to draw a... Oh, we're not going to use that. Just so I remember what I'm doing. Okay, so out color, uniform float, now we're keeping all that. This is changing color equals vector for, actually let's change this. We want to go like this. We want to go like that. So we don't need this line, it's all in one line. And then we'll just take it down here. So there's new planet, and then this will be an example of how to draw the star. Hopefully that will help me in the near future now. We're getting closer. So we don't need that name anymore. This can go at the top. We're not going to use this. We already have our out color. Version 420, I don't know what's wrong with that, but it seems to be an error. Let's pull these functions down. Okay, this one, let's copy that just real quick. Platform, C filter, float type, oh, I got it right here. Hue color, it's going to be different based on what comes in. F color. And the grid is RT. It's right here. That's the grid. So we can just go like that. What's the 2? 2 is the type. Oh, there's different types of platform. Right. And I wanted to, I think they're all going to be 2. That's what I wanted. So what was this one? C filter times CID. Well, we'll play with that later. For now, I don't care. So that's the example of how to draw the star, right? Okay. Cube grid is sent in with the FRRT and the G. I'll have to figure that out in the application. Okay, version 420. I don't know why that's a thing. Go ahead and save that. Visual Studio doesn't use GLSL code. Okay, new planets. So this doesn't use, or no it doesn't. New planet, oh. But the type, okay, 0, 1, 2, 3. RG and V are already used. And so what am I going to do? Position, color, RRT. Alright. Oh, this isn't working for me. Because I already see the problem there, but we'll fix it. We'll figure it out. Okay, so the fragment shader, or the vertex shaders is position, color, RRT. RRT being the type, the grid, and the scale. Because I just did a wonderful job of naming that, didn't I? Should just call it TGS, type grid scale. Oh well. We will figure that out as we go. As we go. Okay. So now we got how to draw the star. So what did we have before in our application? We just had the star. So so let's see if we can do right. Okay, so then we want to take from here. Demo init Voronoi points, init data. So it's just the vertices. Oh, let's take this. Point size enable, that's perfect. So everything's right there. That is what I need. Let's go into here. So that's going to be my init VAO VBO. That's going to replace this. Star VAO. Oh, I should probably change that right now. Changing that right now. Although I don't, because I want to call it system VAO. Hold on, it's going to change a few of these. Poor clipboard, it's just holding on there. System VAO. Okay, good. Oh, star VAO here. System. Oh, duh, this is what I'm replacing. So point size and everything. Boop. Okay, now it's freaking out. It's literally freaking out. Freaking out. Okay, and just for the sake of argument, we're gonna go here, although we're gonna give each one, we're gonna reduce maybe the data that goes in for some of this, the way we do it. Cube grid 32, cube color. We're not gonna use those, but I will initialize, so vertices. Okay, so let's get the vertices array, and it's just this right here, Voronoi. Okay, that's cool, I guess. Update time. So now we're going to go here. We're going to go under the system VAO. There we go. Structure Voronoi, position, color, RRT, num points. Okay, we can do a const thing. Number of points. Let's go 10 to start with. Or actually, let's just do 1 because we want to do the star. That's what I started with. Then we'll add to that. Position 0.8. Okay, so now we need a new init data. Here we go. Now we're getting into business. Init data. Oops, there we go. Okay, looks like it's accepted that. So vertices 0 dot position equals, what is position? Vector 2. Okay, that's all we need. That's right. 0.0. Okay, so far so good. Excuse me. Color. Color RRT. Okay, so what was RRT again? Type something scale. But it was here. Type grid scale. Let's change it. We're gonna change it. Should we change it? Type grid scale. How bold of you. Let's go TGS. Let's just change it so that we can FTGS equals TGS. So that's all we have to do to change that variable name. So TGS equals type grid scale. So long RRT, nice knowing you. Okay, so the vertex shader is there. And we have out FTGS. Let's go into here. We do have a little bit to change here because when we go in with that, okay, so I don't think this function uses it. That's fine. FTGS. Okay. That's all we have to do. Okay, I'm just over complicating it for myself, thinking that I'm freaking out. TGS. TGS, so this should work. Uniform float time, I don't think we use time anywhere. So we can take that out safely. Yeah. And it's just going to call the platform color TGSG. We're going to draw the star. We've still got the do planet, rotation 3. Do we use rotation 3? Doesn't look like it gets used, but it's nice to have the rotation thing. But we don't use it, so we can comment it out just for now. Platform is not used at the moment. We could comment that out as well. I don't know why I want to, but I want to. Or wait, no. It's the other function that's not used. It's this do planet. But yeah, I don't know why I'm trying to make it super simple. So let's see if the code gives any trouble. But that's not going to function just right just yet. So we got the vertices position color. Now we need to go vertices 0. Okay, so for this particular vector 3 type, let's say the star is going to be type 1. That could change because the planets might be. The grid is going to be 32, like the one below here, and the scale will do 1, I think. Or should I be size? That could be size. So what do we want the size to be? Wasn't it 256? Yeah, so then let's set a size here. So I know that we use it here, but let's take that out. Isn't there another program point size where I think that's this one. Whoops. Let's tab it all over the place, please. Okay. Position. So now we can take this out. We don't need to do those. System VAO, find, draw 1 point. Okay, now let's look again at the vertex shader, what we got here. Because we want to put in size. So position, color, TGS. Okay, so FTGS equal TGS. GL point size equals TGS.S. Oh wait, RGB, it's B. That should work. It should work. Game Trader. Okay, so class solar system 001. Is this gonna work? Am I already done? With the transformation. Well, we have the init data here. And then does that actually get called? SS init data. No, but we need to call it right here. And then init the VABAO. And then let's make sure that that function is going to do what it's supposed to do. So it's got all this, right, the vertices, everything there. Okay. Yeah, let's see what it does. I'll be blown away if it works, but... Oh, what we got to here. Oh, we do have a problem. Undefined variable f color. Okay, line 55. Let's just go look at that. What did I do? Where's line 55? Computer? 57. Oh, right here. F color. Wasn't that the in color? In vector 3 F color. F color equals V color. Out F color. What's wrong with that? Did you capitalize it or something? Oh, it's capitalized down here. Excuse me. Pardon me. Excuse me. Pardon me. Oh, so it still doesn't draw anything. Okay. And we get no errors. Okay, so now we just need to see. So what does the SS draw solar system do? Find vertex area, vertex buffer, vertices 0, 3, 2, 3, 3, 6, 8, 0, 1, 2, bind buffer. Ba-ba-bum. Init data. Ba-da-bum. So let's put this back in. Maybe it's just drawn at a certain... Maybe it's just the point thing. Nope. So what are we doing to not draw a point here? It's not the point. No. Wait, what happened? Where's the music? Oh, it's back. Okay, I don't know what happened. There might have been a blip there, sorry. Okay, so distance. Point size enable. Boom, 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 boom. Use. Oh. Did we do the use? Where's the... Yes, use. And do we load shaders? Did we load the shaders here? Game Jam Space Trader 2, there. So 2, position, color, TGS. Out color, out FTGS. Point size equals that, position equals position. Okay. I think that looks good. I don't know what's going on. TGS.B. So when I initialize this, 256 is the 1, 2, and 256. Okay. So that looks good. Color equals vector 2. Platform F color 2, TGS G. And then 1. Platform. So filter type, C filter type, and cube grid. C filter is the F color. That's the one that we got the vector 3 came in and that there. Okay. Out color, vector 4 color. Color equals vector 4. Okay, all that. Okay. So then F all this cube grid. GL point chord. Is there a problem using that? Is that draw the points? Okay, this is the vertex shader. F color position. Okay. Fragment shader. Okay, not sure what's going on. What is this music? I love it. Classroom Mario Strikes Charged. It's pretty awesome. Just saying. Okay, so Solar System, Astro, Solar System. Oh, wait a minute, wait a minute. Oh, wait, no, okay. Never mind. I thought. System VAO. Oh, here we go. Here it is. Okay, so system VAO. We also want system VBO. That was the whole problem. Because down here I'm using these local VAOs, VBOs, so I was losing the VAO. Haven't lost the VAO before. Actually, that's not true, but I just don't remember the last time. Better to see everything, blah, 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 blah. Now let's leave this out to see if it sets the point size in the shaders. Nope, doesn't draw. No errors. Okay. But what did we do? System VAO VAO. Right, we did all that. Okay. Bind buffer. Let's put the point size thing back, because maybe it is that. It is that. Okay, and it draws it. Beautiful. So then it's actually that other. Hold on, I gotta look this up. Spades, gems. Background stars. That's the one class. EKG stars 107. There's the one we want. So we have to enable GL program point size and close that over here. Instead of that one, actually let's just comment that out in case, you know. Okay, run it again. Run it again. Computer, run it again. Is it working? Yes. Okay, that's it. All right. That is very good. Welcome to my solar system. Next, we're going to put in planets. Let me go clean up my juicer. I'll be right back. Okay, we got our star. Let me put this water there. Okay, hello star. Cool. Okay, so this is class solar system. Now where did that one go? Right here. Okay, so now we want to include Voronoi points. So how did this work? Position color. Oh, it just drew all of them, and then this is just because we're only drawing one. So I'm not drawing just one. Right, that's why I made it a function. Okay, alright. So what I've got now is one point. Kirby Fighters 2. So let's draw a planet here. But how do we do a planet? Well, this one had 100 Voronoi points, and it also drew 56 by 32. Okay, that's a lot. So let's have, how would we do this? We're just gonna do this, only scale it down. So okay. So first, initialize Voronoi points for planet. We're just gonna do this for one, and then we'll do this for we'll just draw 10 planets. And we'll get it all into a function. So unlike the star, all the planets are a bunch of points. So how small, detailed, what kind of a grid size, what are we doing? It's a good question. It's a good question. For now, since we're just going to draw one planet, let's draw it in the center of the screen, since the star is up at 0.8. And let's just draw it in the center of the screen, and we'll figure out the size. Then we'll figure out the scale and shrink it down, and we'll get different planets and stuff. Okay. Do you want to make this any bigger? What if we go 512? Oh, that's cool. I think I like that. Wait, is it cosine for the x? I don't think it matters, as long as you're consistent. Parentheses, 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 okay. Could probably also tell by the lack of squigglies. Color. So, oh yeah. So we need to set like up here. Planet data. Because each one is going to need... Oh, that's a good point, because each one we're going to have a color palette. But the Voronoi points themselves will have a position, color, and a TGS. Okay, so that's not going to matter. So what am I thinking? Planet center and radius, choose random element, set point, position, right. So the point... color. For now, let's just go... Oh, I don't have it. Hold on. Do I put that at the top? I think I do. It's fine. So we'll make the points, we'll have their own random color, we don't care. TGS, okay. So each one of these is going to have a random type, grid, and size. Type and grid will randomize. Size will let them all equal a similar size. Let's just go with 16 for now, I think. So type, that depends on here. See, there's 4 types here. And then a scale. Okay. So when we send it in, so then we need to tell it whether it's drawing the star or a planet. So that needs to be based on... See, because if it's the star, we don't actually use any of the other FTGS type grid or size. We use the grid. The type is the same. We don't use type or size. So type will define whether it's a star or a planet, and let's go, for now let's go 4 for the star, so let's go back to the star. So the star was previously type 1, let's go 4. And then these, we're going to go random, 0, 1, 2, or 3 for the type. So let's go GL float 0, 1, 2, or 3. So how do we do that? Just random like that, I believe. And I think that's going to give you an integer 0, 1, 2, or 3. So it's going to float it. Okay. And then we need another float for the type grid. So these also, they had a random grid when I initialized them here with this guy. Oh, 0 or 3, is that? I might steal that, I might come back. But let's go like this. This is a random grid, looks like 2 to 12. That's kind of cool. Let's do that. this flute is awesome. Okay, that should do it. Random angle, radius, set point, position, color. So that's just the initialization for the Voronoi points. Okay, what am I doing? Okay. Let us chill for just a second. So that's going to be 5 Voronoi points, and each planet is going to be 1 planet. So what are we going to do? A 10 by 10? Oh, hold on, I'm going to stretch my legs. Be right back. Okay, so we're going to draw each planet as a 10 by 10, I guess? Okay. Draw points for planet and give them Voronoi point info. So number of points, 101. Number of planets, 1. Okay. V points are all set. Draw points for planet. Okay, so what we're going to do is... Okay, so there's the 10 by 10 grid. Each of them is going to be what size? 16. Does that scale affect the size of the... Are we going to use that? Is that for the size of the... I think I've got that confused with... Sorry, that was a bit loud. I said I think I've got this confused with one of the parameters of the function for generating the grid, but for now we're going to use it as the scale in the function and the scale of the point size. But eventually we might have to figure that out. Okay. Pokemon, let's go! Is it just me or is that really loud? I'm just turning that down a little bit. You know what I might have to do? Let's try this one. Oh, it looks like there's going to be an ad. Hold on, let me mute it first. Then we'll start it. Okay. Is that better? Is that more chill? I think that's a little more chill. Let's go with that. Okay, where was I? Okay, so 10 by 10. And for now, each one's going to be 16 pixels by 16 pixels. And so we're going to have it 160 by 160. Okay, that's good. So then let's go with calculator. 16 pixels, 0.00184. 104. Hold on. So the entire screen is 2 divided by 1920. 00104. Okay. Actually, I like the idea that was it Juice or Mumi Jumala gave me the idea. So let's go like this. X pixel equals 2.0 divided by 1920. Okay, GL float Y pixel equals 2.0 divided by 1080. We'll let the computer figure out the rest. And in this particular case, we want both of them to be multiplied by 16. We're not going to account for aspect ratio yet. We're just going to see what everything looks like. So 0. Okay, so now let's go like this. Draw points for the planet. Give them Voronoi point info. So for each point, what we need to do is calculate position, find nearest Voronoi point, set type info of point equal to nearest Voronoi point type info. Okay, that is the basis of the Voronoi algorithm. Okay, so calculate position. So, or wait, and how do we do that up here? Oh, it's based on the center and a radius from the center. So the center, and it's like, this one's going to be at most 0.25 away. Oh wait, so I defined the radius up there. So 0.5 is the thing. Okay, hold on. I might have 0.5 divided by 16. Oh, so I already have my scale size here. Unless I really want to go by that. So each one's going to be 0.3125. The X and the Y scale. Let's save this thought for now, but we'll go with the 0.3125 thing. Okay. 0.3125. Okay, so 10 by 10. Excuse me. So the position is going to be Not planet data. This is just going directly into vertices. Okay, so vertices are actually going to go. Well, the first one's going to be 1 plus I times 10 plus j. Because the first time through it's going to be 0, 0, j is going to go to 10, I is going to go 0 the whole time. Second time through that's going to be a 1. Okay, good, we're good. So this is the position dot position, right? Okay. Then it's going to equal the center, which is what, planet data, sub 0 dot center. Okay, so in this case it's 0, 0, but you know, normally we want to subtract 5 and then it's going to go out 10. Well, that center it right in the middle, excuse me, center minus so the starting point for all these, actually let's just calculate the starting point up here. So it's the center of the planet minus in the x direction it's going to be in this particular case 5 times 0.03125, and in the y direction it's going to be the same thing. So that's going to be the start. Okay, that's a lot easier down here then, because then we just have to go start planet plus, and then we just do an offset per each one. We're just going to go I times 0.03125, j times 0.03125, and that's it. So that should put each point in a grid right there where the planet's center is. Okay. Now find the nearest Voronoi point, because each one is going to have a different position relative to all these points that are just centered, or all these points that are randomly around the center as well. So find the nearest Voronoi point. So then, I mean, I know how to do that, but I'm just going to grab the code real quick. Calculate position of point. Find the nearest Voronoi point, set the color in RTT based on Voronoi's point settings. So right here. So we just want to have an index, have a distance, cycle through every single index, calculate the distance. If it's less than, then, and then set it equal to that. Okay, I can convert that. Find the nearest Voronoi point. So we're going to use ni for index. That's fine. We can go with 10 though, since there's only 5 of them. So there's 5 Voronoi points. And the distance, the nearest distance, we can also go pretty low number. We'll start with 10. Okay, so CD equals GLM distance, GLM vector 2. So now we're going to go with, this is the Voronoi points here. So we're going to go planet data 0 dot v points k position, and then this, what we're going to compare is do we want to write that out? Start planet plus that. Okay, so let's just go this right here. This is all just initialization, so I'm really not worried about optimizing. And then if that, and then that, and that, vertices. So then down here, color. This isn't T-points, this is right there, boom. This is right there, minus that bracket. And this is TGS. And we're outside the loop. Why do I have K? It should be NI. Nearest index. Okay, cool. And here's this comment here. Okay, so that should initialize that planet. I'm very curious to see if that'll do it. Let's give it a try. Any errors? Anything I messed up, broke? Oh. Oh, it looks like we're okay, except for wait a minute. Why is it? Oh, it's drawing them all just like the stars. Okay, so I didn't that's awesome that I got it to work. Hold on. That's a little I was not expecting that to work. I was expecting errors with it to clean up. So now let's see. So this is going to be 0 to 3. So then in the fragment shader, what I'm doing is, if ftgs.type, which is R, is equal to 4, and 4 was the star, right? So then we're going to do this. Oh, I forgot about the comment. Okay, and in this case, we can change this later, but we're going to go else color equals vector 4, and we're not going to draw the platform. We're going to draw a do planet with the center and the radius of the planet. So we need to know do planet. Uh-oh. Why didn't that fill in? I don't know. That's okay. Oh, that's right. This is Visual Studio. So the center and the radius of the planet. And that should return a color. Wait, no, it doesn't. Does it? It sets the color and everything in there. So let's just do that. So we're just calling the function. With those parameters. So let's see what that looks like. It doesn't draw it. Well, there's no errors though. Okay. So do color, do planet 0, 0, 0.25. So 0, 0. And 0.25 goes in there. Oh, because these aren't window coordinates. Right. So for 0, 0, I am going to need that 960 and 5. 540. And then in pixels, oh boy. Trouble I get myself into. So 0.5 is, the radius is 0.25. So how many pixels is that? Well, if the whole screen is 2, let's just guesstimate 150. That gives a little weird, gives a little window, and look at the way it drew some of the points. Okay, it looks interesting. Okay, so this is why I've only done this in a demo, and why it worked right in the center of the screen with all this. So, So I do need to account for aspect ratio and all that fun stuff. But for now, let's go back to here. And let's increase those to 32. So we'll get bigger points inside. Oh, there we go. You can see the circular shape it's trying to draw, but the points are not vertically, horizontally it looks like they might be, but vertically they're not spaced correctly away from each other. So, and 135 is that's a difficult one. It's hard coded into the code here, so let's just go smaller by like 125, or let's go down to 100 even, 100. See if that'll give us at least a circle. It's closer. Okay. Now that's closer to what I was expecting. Let's go to 80. Yeah, see, there's a planet, but we're getting closer. So 960, is that right? 1920, 1080, 540. Okay, I think that's right. I think that's right. Okay, so then let's go back to the initialization code here. The start position. Because they're each now being drawn at 32 instead of 16. So that means we can double this. 3125, that would be 625. There we go. For the center, and then each one's going to be 625. 625 like that. Distance, all the other stuff is good. Okay, now they're too far apart from each other in the X direction. What did I do? Let's just leave it like that, I think. We're just putting them closer. Okay, now it's not starting over far enough, which means that this is going back too far. That's aspect ratio affecting me, I think. Yeah. Okay, that's a little bit closer to what I was envisioning for a planet. So the only problem with this now is the position of the planet needs to be sent in for each 10 by 10 group of points. Oh, maybe we should send it in as a uniform. We could have the planets. Okay, hold on. Because what are we making for the planets, or we have planet data, number of planets. Okay, so each one center, and that's used to calculate. Okay, but we want window coordinates. Let's call it window center. Okay, NGL float window radius. So for each one we'll have to calculate that, and then we could just create a uniform. Excuse me. Okay. All right. I love that I'm streaming because I kind of feel a little bit of kind of a compulsion to actually complete this, even though I kind of want to just do it tomorrow. So let me take a quick break. When I come back, I will do that. We will convert them to window coordinates for the center, for the radius, and then we will send it as a uniform instead of doing the update like I'm doing it manually like that. And then we'll be ready to draw 10 planets after this. Okay, I think we can do this. So window center, window radius. So each time oh, that won't work unless we draw the points, because you'll have to update the uniform and then send the draw call. Update the uniform, send the draw call. Oh, unless we could use the geometry shader to do this. It might take a little bit more planning, but because with the geometry shader, it would be one call. We could send in we could send in the 1 point. It will draw a little grid. It will convert the center point to window coordinates and the pixel radius, and then it will send that to the fragment shader each time as it amplifies the point. Okay, so I'm not going to do that on this stream just yet, but I'm going to do that for the next iteration of this, because that's what we need to do. Okay, that'll make sense to future me. We'll be able to figure that out. It's a little bit more work, but in the end it'll be worth it. That'll be really cool. Okay, then the other thing is going to be the platformer, the 2D platformer. Actually, we'll probably be using the geometry shader for that too, because we're going to go back and look at our old platformer. We're going to look at a jump around, and a jump size. And then we're going to, based on the jump size, that's going to be like the maximum that the platforms will be away from each other. And or yeah, so we'll have to figure that out. So, alright, so we're going to call this solar system part 1. So that was the figuring out how to draw the solar system. And so I'm doing this basically completely from scratch. I have a lot of code that I'm just kind of putting together from stuff that I've done over the years. And it's really going way better than I thought. So let's look again at what we got. Did we mess anything up? Okay. I mean, that does look like a planet if you count something really cheesy. So that's fine. But we're going to have something better. We're going to have something better for the stuff. Okay. So thanks for watching. Thanks for tuning in, everybody. Had the clash. That was great with Zombie Whale. And, have a good one. Let's see.